Solving quadratic inequalities. In this video, we are going to solve the quadratic inequality x squared plus 8x plus 15 is greater than 0. In the Introduction to Quadratic Inequalities video, we saw that when we are trying to solve quadratic inequalities, we are trying to find intervals along the x-axis where our graph was greater than 0 or less than 0. We found that the intervals of x values which result in the inequality being less than 0 are represented by the sections of the graph which are below the x-axis, and the intervals of the x values which result in the inequality being greater than 0 are represented by the sections of the graph which are above the x-axis. So in this example, we're trying to find intervals of x values which result in the inequality being greater than 0. So we're looking for sections of the graph which are above the x-axis. So in order to be able to sketch our graph, we need to look at the associated function. So the associated function in this case is y equals x squared plus 8x plus 15. Now, to be able to find where this graph is above the x-axis, we first need to find where the graph crosses the x-axis. So the second step is find where the graph crosses the x-axis. So this means we must find where x squared plus 8x plus 15 equals 0. As this is a quadratic equation, we solve this using the guide number method. So step 1 in the guide number method is we find the guide number by multiplying the x squared coefficient, which in this case is 1, by the constant, which in this case is 15. So we have 1 by 15 equals 15. So our guide number is 15. Now the second step is we write out all the factors of the guide number. So the factors of 15 are 15 by 1 or minus 15 by minus 1, 3 by 5 or minus 3 by minus 5. So they're all our factors of 15. The third step is we pick the factors of 15 which add to give us the x coefficient in our original quadratic. So in this case, the x coefficient in our original quadratic was 8. So the factors of 15 which add to give us 8 are plus 3 and plus 5. In step 4, we split the x term in the original quadratic into two terms using the values we found in step 3. So we can write this as x squared, and we're going to split our 8x up into 5x and 3x. And then we have plus 15 equals 0. Now in step 5, we proceed by factorizing by grouping. So we can group it as follows: x squared plus 5x plus 3x plus 15 equals 0. So if we take x out of the first one, we're going to be left with x plus 5. And if we take 3 out of the second one, we'll be left with x plus 5 again. So our factors are going to be x plus 5 by x plus 3 equals 0. Now we know that the product of two values is 0 only if at least one of the values is 0. So this is going to give us x plus 5 equals 0 or x plus 3 equals 0. Then we can solve these, so we get x equals minus 5 or x equals minus 3. So now we know where our graph cuts the x-axis. If we find where our graph cuts the y-axis, we can accurately sketch our graph. So our function was y equals x squared plus 8x plus 15. So x will be 0 where it crosses the y-axis. So then we're going to get y equals 0 squared plus 8 by 0 plus 15. So this will give us y equals 15. Now we know our graph cuts the y-axis at 0, 15. And we found already that our graph cuts the x-axis at minus 3, 0, and minus 5, 0. So the graph of our function looks like this. Now we have all the information we need to solve our original inequality, which was x squared plus 8x plus 15 is greater than 0. To solve it, we need to find the intervals where the graph is greater than 0. In other words, where the graph is above the x-axis. So by looking at the graph, we can clearly see that the graph is greater than 0 in this interval and in this interval. This tells us that our solution to the inequality x squared plus 8x plus 15 is greater than 0 is when x is less than minus 5 or when x is greater than minus 3. So now look how the graph is above the line, in other words greater than 0 at all the x values less than minus 5, so minus 6, minus 7, minus 8, minus 9 and so on, and for all the x values greater than minus 3, so minus 2, minus 1, 0, 1, 2 and so on.